So I'm going to talk about computing on the edge, bringing serverless to you fast. First, a little bit about me. As mentioned, I'm a developer advocate at Cloudflare. I am also a serverless advocate in general. I am an IoT author, and I Twitch stream IoT software and hardware development. And everywhere I am node botanist, because that username isn't usually taken by the time I log into whatever service I'm planning on using. So on the edge is a very overloaded term. It can mean a lot of different things to a lot of different people. So what do I mean by on the edge? What I mean is as close to the user as geographically possible. And for serverless, that means lots and lots of data centers all over the world. I'll talk more about why here in a bit, but basically all over the planet. We want data centers all over the place. And at Cloudflare, we have that. We have this map is actually woefully out of date. We have over 165 data centers live across the world. And that number is growing quickly. I know this because I just built a giant LED map of all of them, and man, that's a lot of LEDs. But it's a lot of fun. So Cloudflare data centers are an example of this. There are a lot of distributed networking systems that are trying to create edge computing systems by putting data centers as close to the users as geographically possible. So what are the benefits of this? What are the benefits of serverless edge computing, as in serverless compute as close to the user as possible? One of the main benefits is latency. The best way to reduce latency is to be geographically closer to your users. If you are in Australia and you're pinging a server really anywhere, it's going to take forever unless it's geographically close, and that's going to be pretty rare, right? But let's say you're in Europe, if you're trying to ping a server in San Francisco, that's going to take longer than a server that is also in Europe. So one of the benefits of serverless compute being available as close to the user as possible is latency. Also, with serverless, specifically, you can reduce the number of round trips to the origin if you use serverless with dynamic routing, if you use serverless with a caching system, if you use serverless and say, okay, I want to create, on each data center, I want a database essentially that acts like a cache. And so if it doesn't have to go all the way back to wherever my app is hosted, the better. So serverless on the edge specifically, you can, when you think about it from a serverless perspective, you can create a system that has to go to the origin as few times as possible, which again, decreases latency. Redundancy, really handy. If say the server goes down, let's say you're in London and the London data center goes down. Well, if there's a data center in Berlin, okay, just reroute the traffic to Berlin. It'll be a little slower, but it's still there. And if you have up to hundreds of data centers, that redundancy becomes extremely useful because you can have multiple data centers go down. You could have entire, like let's say US, you could have the entire West Coast go down. Okay, as long as the Midwest is still running, we can still go get those West Coast people to servers. So, and you don't gain a ton of latency, again, if you have that spread out map of data centers. But if you're, again, to go back to Australia, let's say you only have a data center in Sydney and then you have another one in Singapore. If Sydney fails and you go to Singapore, it's still going to increase in latency. But the redundancy makes sure your app still runs, which at the end of the day is really, really what we care about. Oh, there we go. Scalability. So a big, huge bonus of serverless in general, no matter what architecture you're using, is going to be scalability. The ability to just handle as many requests as you need to, just spin up as many instances of your service function as you need to. The scalability is increased by computing on the edge by geographically distributing your load balancing. So it's kind of like a form of natural load balancing. So unless you're geographically restricting your app, if it's a global application, you've got some natural load balance from the fact that you are having users ping data centers that are literally all over the world. And like I said, natural scalability of serverless, so you multiply it by that multiple data centers. It makes it even better. There are other ways to reduce latency in serverless. I'm going to talk specifically about how we do computing on the edge and serverless on the edge, and that's Cloudflare Workers. So they're slightly different in that we do not spin up an entire OS or an entire workflow for you. We run everything in V8 isolates. Isolate is a class name from the V8 engine. And so basically, instead of it spinning up a process for each individual serverless function, you spin up an isolate for each individual serverless function. And that adds a real benefit, which is the other way, eliminating cold starts. So when you don't have an OS to start up, when you don't need Node to start or Python to start or Java to compile, and you're just running a V8 isolate, no cold starts. Who here never wants to have a cold start again? Yeah? Yeah. I see more and more hands the more I have to give the talk. I think just more people know what cold starts are. But yeah, no OS, no container, no cold start. So I'm going to walk through a demo. I'm not going to live code. I've learned my lesson. This is a video recorded demo. It's still coding. It's just much faster than I can type, and I can explain what I'm doing instead of mistaking my typing all the time. So this is the Cloudflare Workers editor, and what we're creating is an A/B test of a serverless function. So we want half of people to get a certain piece of functionality, and we want the other half to get a different piece of functionality, right? Okay, so the first thing I'm doing is adding a binding to a worker's KV, which is a key value store that you can attach to a worker that also deploys to each of the data centers. So that's just so I can store something for that thing that's conspicuously hanging off the front of the podium. So the first thing I'm doing is adding a name to my experiment. I'll call it Serverless Days Boston. And then I establish a group, and I'm not saying what it is yet. And is new is false for now. So then I read the cookies that come in from the request, and I check for includes the name of the experiment and whether it equals control, if it does exist, or whether it equals test. That's the other name I used. So control and test. And so if it's control and test, it will assign it. Otherwise, there's no group, and the group will be decided by math.random. If it's less than 0.5, you will go to test, and that random should be control. That's like one typo from this. Is new is true if you didn't have a group. Then if group is test, it basically, I cater the response to be test group or control group. And then finally, I'm doing some other stuff down here where I set the cookie if you're new. That way, the cookie persists, and you get the same functionality when you hit refresh until you clear your cookies. And then I'm storing the date timestamp in the KV when you hit test or control. And that's what's hanging off the front of the podium. When you go to the URL that I'll show on the next slide, it'll say control group or test group, and that will eventually, internet, show a blue dot if you are a control group and a green dot if you are test group. So that's my IoT edge of the demo. So this is my A/B test that I've got, is you are assigned a cookie based on a math.random if you don't already have the cookie, and then you are given a different piece of functionality, and this is deployed. When I hit deploy, this is sent to every single data center, so including the KV store, which is pretty handy. Forward, there we go. So that's the URL, if you'd like to try it out. So if you go to nodebotnist.dev/a-b, no dash between the A and the B. I don't know why I put that there. Just ab-test, you'll end up seeing control group or test group, and eventually persistence will prevail, and you will show up on that little LED screen in front of the podium. Okay, so the question now that you're thinking of is, I just made the leap to serverless, right? Like I just did all this work to get my app from servers to serverless. Why should I make the leap from serverless to serverless on the edge? Well, for that, I kind of want to reiterate, you want to get closer geographically to your users. That's really the only way beyond what we're already doing in serverless to reduce the latency between you and your users. There's just, the speed of light is a constant. We have proven this over and over again. And we wish data moved at the speed of light all the time. It does not. So you need to decrease the distance geographically between you and your users in order to create that low latency application that you're dreaming of. Sorry, the sentence escaped me there for a second. Increasing redundancy. You want your app to stay up regardless of whether, regardless of whether a data center goes down or an entire set of data centers goes down. You want to be able to reroute your users to another position, and you want that to increase their latency minimally. And again, the distributed edge network is really going to help you there. And then increasing scalability. Scalability is great in serverless. Most of the major serverless providers are already really great with scalability, but you can multiply your scalability by the sheer number of data centers. Before I go into the last slide, I'm going to show a little more of my demo because I planned in case I spoke too fast. All right, so, right, you can't see this screen. Right. Escape. This is why I'm glad on my computer. Right, there we go. And that's true. If you ask me to debug your code, I will not use spiders. All right, come on. There we go. So here's the editor. Come on. There we go. I love how Mac randomly decides what side to put the external monitor on when I'm using an external monitor. Sometimes it's top, sometimes it's left. So this is the function that I'm running. And I know I went over it really quickly in the video, so I'm going to go a little more in depth into it. So again, pulling out the headers with the cookie. And I want to make sure the cookie exists, because if it doesn't, I just want to ignore it entirely and set a new one. Otherwise, again, I'm checking for control or test. And otherwise, I want a 50-50 split. But if I want to change that, let's say I want only 40% to go to control, or 30%, or 20%. You can change that and then hit this, and off it goes. And then bloop, click this one more time. All right, so again, if group is test, so the group is set. I don't know why it keeps showing that 1100 error before showing. And if I hit refresh, this doesn't actually keep a record of the cookie. So when I hit refresh, sometimes it will show control group. Come on, there we go. So control group or test group. I can also test it through here. One test. And I got my test group. And you can see Serverless Days Boston is the name of the experiment. So you can set multiple A/B tests running at the same time. Just name the cookie parameters, different things. And again, our responses are new test group and control group. And one of the questions I get regularly about this specific implementation is, does this limit me to JavaScript? Because one of the benefits of serverless is you can do it in just about any language you want. You can bring your own runtime in AWS. This particular implementation, Cloudflare Workers, supports anything that runs in WebAssembly as well as JS. Because we run V8 isolates, we can use WebAssembly. So Go, Rust, C++, it's really great for extensibility. And I have a lot of really positive opinions on WebAssembly in general, not just in the context of serverless, that I would be happy to talk about on the hallway track. But with any new implementation of serverless, you don't want to roll back previous abilities that we had to use different languages. So luckily, we managed to find a way that uses WebAssembly so that you can use languages that you love if you don't love JavaScript. Who doesn't love JavaScript? Don't answer that. So, no, I actually love JavaScript, and I am a JavaScript dev. But someone said something about every JavaScript developer. No, I love JavaScript, and I'm still a JavaScript dev. Anyway, let's put my slides back up. All right. So I ran really short, but hopefully that's good for y'all. You'll get an extra break. I will be taking questions in the hallway. That's usually where I get the most of most of my interaction is in the hallway. That way, but I'll get far away enough from the door that I won't bug the next speaker. Anyway, Node Botanist on just about every social media platform you can think of, and Kas@cloudflare.com if you have any specific questions via email. That is my work email, and will be treated accordingly. So, if you send something unprofessional, I will just discard it. But other than that, Carl Sagan and I both think you are awesome. And yeah, thanks so much for listening.